So the first step to figuring out where all the perpendicular bisectors intersect was just to play around with moving point D and trying to figure out what made it work. So my first thought was that it had something to do with the length of the sides or angles, and something like opposite had to be congruent. So I put it around here. Obviously that did not work. I also set up measurements of the sides and the angles just to observe, but nothing, at every point where it intersects, none of those had showed any sort of visible pattern that gave me a clue into what um, what the condition of where point D was needed to be. Um, so I set up a trace function. Well, I noticed that on all the points where D intersected, I could kind of just keep moving it around and rotating it. So we set up a trace function and traced where point D intersect, and noticed that it kind of went in a circle. So I put a circle at the point where they all intersect, and then out to point D, and noticed that all of the points were on that circle. So I came down to this shape and then made my circle first, and then put the quadrilateral in the circle, and noticed that with all 4 points on the circle, the perpendicular bisectors are always intersecting no matter where you put the other points. You can even like overlap them so it's like twisted, and they still intersect. Um, so in thinking about why this was happening, I thought it had something to do with angles. That was my first idea. But then I was just staring at it, and it probably still has like something to do with angles, but I noticed that the sides cut off this little section, and the perpendicular bisector here is bisecting this section, which made me realize that it is also just cutting the circle in half. It's a bisector to the circle as well. And so is every other perpendicular bisector to the sides. They all bisect the circle, and so they all intersect at the center point of the circle. Yeah.